Thank you. Okay. So I'd like to dedicate this to the memory of my friend, our friend, Brian Troy Scott, who first invited me to speak about the ridiculousness of the universe in his creative writing class at the Art Institute of Chicago in 2007. I was a grad student studying physics and cosmology at U Chicago, and Brian had an amazing way of seeding and encouraging creativity among his friends. I mean, it was like addictive and contagious. And there's a direct lineage between him inviting me to speak to this class about the ridiculous of the universe, and then us starting Astronomy on Tap here, I don't know, like 8 years ago, whatever that was. Brian passed away in 2013 at the age of 37 from cancer, and he was a very important influence in my life, and we miss him a great deal. Sam's known him even longer. They met first day of college. Brian, Sam, and I, and our other friend Emmett Kelly played in a band together called Psycho Jail around 2007, which was a joke band, kind of. And then a few years back during the pandemic, Emmett asked me to record some crazy cosmic shit. And I told him I was too busy, and I thought it was kind of a stupid idea, but it got me thinking about this specific project. And so that band, Psycho Jail, that was Brian's name for that postmodern pop cover band thing, and Carl Sagan and just drugs kind of influenced my placeholder name for this project or whatever it is. And then Bitsy, the bartender that's normally back here, once told me that Astronomy on Tap could be like way cooler if there were explosions and music and shit. And so that gave me the idea of thinking about this project as part of Astronomy on Tap. And you know, I knew we had a very supportive community, and I felt kind of safe to experiment and do something weird and personal. And Seth and Patrick at Pygmalion have always supported us, and Jim from 25 O'Clock has given us a home, and Matt Cho before that gave us a home in the early days and got us going. So thank you, like everybody here and everybody that's helped us along the way. So all of this came together the last week. So it's kind of improvised, definitely shambolic. And I'd like to thank my co-artist Sam Wagner on sounds and Patrick Aleo here on visuals. We haven't done this before, and we might not ever do it again. And this is about 20 minutes, and it's supposed to be like meditative, hopefully profound. So just please leave now if you don't have the patience for it, or if you find this kind of shit banal. So buckle up, prepare yourselves. Cosmic Psychonaut. In the beginning, there was energy, and then something, we don't know what, made the universe expand. In a billionth of a billionth of a billionth of a billionth of a second, space was stretched faster than the speed of light. And the universe expanded to a size that was a billion, billion, billion times larger than it began. And the tiny, random quantum fluctuations that were there in the beginning imprinted the large-scale structure of the universe. The smallest things connecting the biggest things. This is called inflation. We don't know why it happened, but we can see its effects on the universe today. We see it on the sky. We see it in the distribution of galaxies. We are still swimming in it 14 billion years later. We can look back in time to almost the very beginning. To when the universe, if it were a human lifetime, were a mere 1 day old. We observe the afterglow of the beginning. That specific moment in time after the universe had expanded and then cooled enough that all the electrons found all the protons and formed atoms, and the universe became neutral. What a curious event this was, that such different constituents, a proton made of quarks with a total charge of 1, and an electron, a fundamental particle with a fraction of the mass and exactly the opposite charge, were made in exactly equal number. And from this pairing of particles, you get the first, the simplest, the lightest, and the most abundant atom, hydrogen, the stuff of which stars are made. And once you have hydrogen, the photons in the cosmic soup of the early universe could stream freely and not scatter, and we could see. We can take an actual photograph of the universe as it was back then and examine it, discern its notes, and infer its composition. The weird thing is that most of the universe is not made of the same stuff as us. We are made from the guts of ancient, dead, and blown up stars. But the universe is filled with dark energy and dark matter. So called because we don't have any other idea of what to call them, and they don't interact directly with light. Edwin Hubble first observed dark energy in 1929 with film photography and the world's greatest telescope, and a technique he took from a woman named Henrietta Leavitt, and some data he found from a man named Vesto Slipher. But Hubble put all these things together and saw that the universe was expanding. The further away a galaxy was, the faster it was moving away from us. Today, thanks to the Second World War and the space race, we have sophisticated telescopes on the ground and above us in the sky. Amongst the greatest human technical achievements in all our history. and we use them to study this dark energy down to the percent. And the dark energy is making the space between the galaxies expand. And the expansion is getting faster and faster as we speak, and we don't know why or what it is. Dark matter is the stuff that holds galaxies together. It makes up the bones that support the largest structures throughout the cosmos. Fritz Zwicky first noticed it in 1933, before he went on to design rockets. And Vera Rubin perfected its study, even though at first they wouldn't allow her to use the telescopes. We have no idea what dark matter is, but there are many different and independent ways in which we can tell it's out there, all around us. And then we get back to the normal stuff. The protons and electrons and a sea of neutrinos which are whizzing through us and around us all the time. This stuff, the so-called baryonic material, makes up 5% of the universe, but it's mostly just gas, the stuff between the stars. Stars and rocks, like the planet we are sitting on right now, make up less than 0.5% of the mass of the universe. Just 0.5%. Hold up your hand. Consider the fact that 10% of you, by mass, which is essentially all the hydrogen atoms locked up in water molecules throughout your body, was formed during the birth of the universe. In that first 20 minutes of cosmic time. 10% of you is older than civilization, than every mountain on earth, older than the stars. But the remaining 90%, which is mostly oxygen and carbon, had to wait billions of years to be formed. In the cores of massive stars, which spew the heavy elements out into the cosmos when they stop burning, and churn and mix the clouds of gas in space until at some point things settle down, cool, and condense enough for a star to be born. And when that star formed, it came with a disk of detritus and debris, and maybe if things were just right with some planets, with a rocky surface and some water and a bit of atmosphere. And if everything was just so, such that the surface of the planet were not too cold, such that water was ice, and not too hot, such that the water was gas. And if the center of the planet remained hot enough, such that its iron core remained molten and freely spun and generated a magnetic field, then chemistry and complexity and entropy could really come into play. First, with rock slime, and eventually bacteria, which ate up all the carbon dioxide and excreted oxygen, slowly poisoning their atmosphere, but making it possible for even more complicated things to arise. First fish, then giant lizards, then little rat-like animals, and finally, us, some sort of apex. And why are we significant? Because we are able to look out at the stars and wonder, discover the laws of physics, or destroy cities by combining the power we learned from the stars with the power we found in the atom. And yet, we are still too insignificant to leave our little rock out in space, and still too stupid to learn to be kind or even to take care of our home. And that is where we are now, at a curious little crossroad in the development of a species, in the evolution of time. It sort of begs the question, how special are we? Was there once other life in our solar system? Are there other creatures circling around stars beyond our own? Why are we here? Was it inevitable? Was it necessary? Was it happenstance? Will it be so ephemeral that not even our Earth will remember us after another billion years? Does it matter? By what standard of objectivity could we even say? Can we claim any spiritual superiority over an octopus, which we drag up from the sea and eat with a squirt of lemon and a pinch of salt? Or a computer, which we train to make us redundant? Or a tree, the oldest living thing we know. The stars are slowly dying. Their fuel is being used up. 10 billion years from now, only the small red ones will still burn. The bright blue ones having long since perished. And not enough reservoirs of gas will be left to birth any more. The universe will continue to expand. The distance between the galaxies growing larger every day, every year, every millennia, until 1 billion years, and then 10. Until everything is cold and empty and dark, and then eventually gets sucked into a super massive black hole. No one will be around to think back at how good we had it. So stop now and take a moment to look out at the moon in our backyard, at the stars in our heavens, at the black space in between that extends to infinity. We are all part of the cosmos. You are all intimately connected to it. And all of us are in this thing together. Once again, that was Patrick Aleo on video and Sam Wagster on music. Thank you.